Electric transformers. We see them everywhere, but often take for granted the big part they play in our everyday lives. Their job is to transform the high voltage from electrical power lines to the lower voltage that's suitable for home use. Without them, raw electrical power would be virtually useless to the average person. Transformers are a critical part of modern life. But did you ever stop to wonder what's inside those canisters? To build a transformer, workers start by taking paper that's coated with epoxy glue and tape it to a wooden block. Next component, an 1/8 of an inch thick aluminum strip. It's a metal that can withstand the heat that a high voltage current produces. As the block is rotated, the paper and the aluminum strip are wrapped around it. An aluminum bus bar, called the low voltage lead, sends low voltage current out from the transformer. Workers fold the lead and move the unit to another rotating block for more wrapping. The insulating paper has epoxy glue on both sides. This glue will later melt and bond several components in place. On the next block, a worker tapes on more epoxy paper along with epoxy-coated copper wire. He covers the paper. Then repeats the same process, forming a second layer of copper wire. He solders a high voltage lead wire to the copper wire, then rolls yet another layer of copper wire. Next, he welds on what's called the lead wire out, the wire that'll protrude from the transformer's cylinder, and attaches vinyl-coated wires that'll connect to different voltages out of the transformer. This completed unit is called the coil. Now, using electrical steel, workers build the transformer's other main component, called the core. The coil and core are tightly secured together with metal strapping, which will help to fix the assembly in the tank. Then it's into an oven, where they bake for 8 hours at 275 degrees. The heat improves insulation by removing any traces of humidity. It also melts the epoxy glue, fusing together the paper, the aluminum strip, and the copper wires. The assembly now goes into a steel tank. A rubber gasket is hammered around the perimeter, and a grounding wire is bolted on. Then 3 thermoplastic bushings are inserted. Workers connect the low voltage lead to the thermoplastic bushings, then bolt the bushings to the tank. They adhere an oil filling guide to the side of the tank, then position an automated filling machine. A machine fills the tank with mineral oil, drawing a vacuum to make sure the oil disperses throughout the coil and core. The oil is used for its thermal and insulating properties. An internal fault detector will alert maintenance crews if there's a short circuit. A worker runs lead wire through the thermoplastic bushing and secures it in place. Next comes the high voltage connector. Finally, the tank cover is bolted shut. The transformation, so to speak, is finished. Before transformers go into service, they have to undergo some truly electrifying tests. This equipment simulates a 145,000 volt lightning strike. Then it's into a water tank to test the transformer for leaks. If it passes muster, it could soon be appearing on a pole near you.